Hello class, welcome to Basic Electrical and Electronics Engineering or EC 100. And our topic for today is DC circuits, which is a series connection. So we have here, next slide. So we have here the flow of our discussion. So we have series circuit, the parallel circuit, the formulas and examples, and then the measuring with device. So I have here two types of arrangement. So there are two ways which an electric circuit can be arranged. We have series and parallel. So I have here a sample circuit, a series circuit in which there is only one path for current to flow along. In the series circuit, so as shown in the figure here, the current is the same in all parts of the circuit. So the current that passes from here to the different resistors from resistor 1, 2, and 3 are all the same. So we have current source is just equal to the current that passes through all each resistance. Next, we have here a route for the flow of electricity that has only one path. So again, the flow of electricity or the flow of current is only one path. And then a series circuit is a closed circuit in which the current follow one path. A break in any part of a series circuit stops the flow of current in the whole circuit. So here we have an example. So the total resistance is equal to the sum of all the individual resistance. So we have here this part. So we have here R1, R2, and then we also have here R3. And then the total resistance is just equal to the sum of all resistances. So we have R1 plus R2 plus R3. Next, in series circuit, the current flowing in all parts of the circuit is the same. So the current from the current source, which is here, is just equal to the current that passes through the resistor 1, to the resistor 2, and the resistor 3. So we have here an equation where I source, or the current source, is just equal to the current in resistor 1, equal to the current in resistor 2, and equal to the current in resistor 3. Another pointers, we have here, the sum of the voltage drops in a series circuit is equal to the applied voltage. So the sum of the voltage drops, so what do you mean by the voltage drops? The voltage drops are voltages that drop from each resistance or loads that found in the circuit along with the path. So we have here voltage drop in resistor 1, so we have V1. We also have the voltage drop in the resistor 2, which is V2, and then the voltage drop in resistor 3 is V3. So the total voltage is just equal to the applied voltage or your source, DC source. So again, the voltage drop across each individual resistance depends upon the value of resistance. So we know from Ohm's law that voltage is equal to the current multiplied by resistance. And we know that in series circuit, current is the same in all resistances, in all parts of the circuit. So the voltage now can vary or depends only in the value of each resistance. So the higher the resistance, the greater the voltage. The lower the resistance, the lower the voltage. Next, we have the total voltage across a series circuit is equal to the sum of the voltages across each resistance of the circuit. So we have here the voltage drop in R1, which is the V1, V2 in R2, and then V3 in the resistor 3. So the total voltage is just equal to the sum of all the voltage drops across each resistances. So we have V1 plus V2 plus V3 is just equal to the source voltage. Next, we also have the total power, which is the total power across a series circuit is equal to the sum of the power across each resistance of the circuit. So we have here the power in resistor 1, the power in resistor 2, and the power in resistor 3. The summation of all the power that is used in each load is equal to the total power of the circuit. So next, so we have here the formulas. So we just summarize what we've learned from the past slides. So in general, in series circuit, the electric current is just equal to all the nodes. So the current from the source to this source into this load to this load is just equal. And then the voltage source is just, the total voltage is just equal to the voltage source. And the voltage source is just equal to the voltage drops of each resistances. And the total resistance is just equal to the resistance of each load. So we have R total, or R source, is just equal to R1 plus R2 plus R3. Example to measure resistance. So we have here a circuit, and we have here R1 is equals to 15 ohms. We have R2 is equals to 5 ohms, and we have R3 is equals to 30 ohms. Now, what is the total resistance? So we know that R total is just equal to the sum of all resistances in the circuit. So we have 15 ohms plus 5 ohms plus 30 ohms. So we have a total of 50 ohms. And these are the measuring device. So we have here a multimeter, is a measuring device that can to measure resistance, voltage, and electric current. So we have here a digital and the analog multimeters. Another example, so we have example, determine the following quantities for the circuits shown below. So find the equivalent resistance. The equivalent resistance is just equal to the REQ, or R total. Next, the total current from the power supply. Next, find the current through each resistor, and then find the voltage drop across each resistor and the power dissipated in each resistor. So for our first example, we have here a 125 volts, the voltage source. We also have here 3 resistors. So we have 20 ohms, 30 ohms, and 50 ohms. So let's say this is R1, this is R2, and this is R3. So what we're gonna find is the REQ, or R total, is just the same. So the REQ for the series circuits, we just have to sum all the resistances. So we have R1 plus R2 plus R3. So we have 20 ohms plus 30 ohms plus 50 ohms. So we have 50 plus 20 plus 30 is 50 plus 50, that would be 100 ohms. So REQ is equal to 100 ohms. Next is the total current from the power supply. And we know that the voltage is just equal to the current multiplied by the resistance. So we have here the total resistance, and then we also have here the voltage source. So we can now get the current, and remember that the current in the source is just equal to the current that passes through all the resistance in the circuit. So we have here current is just equal to voltage over resistance. So current is just equal to voltage over the resistance. So we have here the voltage is just equal to 125 volts. And we have the total resistance is 100 ohms. So we have 100 volts divided by 100 is just equal to 1.25 ampere. So the next question is the current through each resistor. Again, in series, the current that passes from the source is just equal to all the current passes through all the resistors or all the nodes. So we have the I at R1 is just equal to current in the resistor 1 is just equal to 1.25 amperes. And so with the IR2 is equal to 1.25 ampere. And the current at the resistor 3 is also equal to 1.25 ampere. So another is the voltage drop across each resistor. So the voltage drop in each resistor. So we have the Ohm's law again. Voltage is equals to IR. We have the current, which is the same. So we have 1.25 ampere. And then we have the value of resistances. So the 20 ohms, the 30 ohms, and the 50 ohms. So we can get the voltage drop in each resistor. So we have here at V1 is equal to IR. So the current is 1.25 ampere multiplied by the resistance. So we have 20 ohms. So we have 1.25 ampere multiplied by 20 ohms is equal to 25 volt. So we have V1 is equal to 25 volts. Then we also, so we have V2 is equal to IR2. So we have 1.25 ampere multiplied by the resistor 2 is 30 ohms. So we get 1.25 multiplied by 30 is equal to 37.5 volts. So we have V2 is equal to 37.5 volts. V3 or voltage drop at resistor 3 is equal to IR3. So we have current is 1.25 ampere and the resistance is 50 ohms. So we have 1.25 multiplied by 50 ohms. So we get 62.5 volts. So we have V3. Next is the power dissipated through each resistance or resistor. So we have power 1 and then P1, P2, and P3. So we know that power is equal to voltage multiplied by current. So we have voltage. We also have current. So we know the voltage drop of each resistor. So because we already get the voltage drop, and then we all know the current is the same. So at P1 we have the voltage drop of 25 volts multiplied by current. So current is 1.25 ampere. So we have power at resistor 1 is equal to 31.25 watts. Next, we get the power at resistor 2. So we have V2 multiplied by current. So we have voltage drop in resistor 2 is 37.5 volts. So multiplied by 1.25 ampere. So we get 48.875 watts. So we have P2. So next is we get the power dissipated in resistor 3. So we have P at the resistor 3. So we have V3 multiplied by I. So we have 62.5 volts multiplied by 1.25 ampere. So we get 78.125 watts in PR3. So this is all we get. So the total resistance is 100 ohms, or the equivalent resistance is equal to 100 ohms. The current is equal to 1.25 ampere. And we know that the current is just the same through all the nodes. So we have the current at resistor 1 is also equal to 1.25 ampere, and we have the current of resistor 2 is just also equal to 1.25 ampere, and so on with the current in resistor 3, which is equal to 1.25 ampere. Next is we get the voltage drop in each resistor. So we know the value of the current, and we also have the different values of resistance. So we know that by Ohm's law, the voltage is just equal to the current multiplied by its resistance. So we get we use the current, which is 1.25 ampere, multiplied by R1 is 20 ohms, so we get 25 volts. For the voltage drop in R2, so we have 1.25 ampere multiplied by the resistance is 30 ohms, so we have 37.5 volts. And then for the voltage drop in resistor 3, we have the current of 1.25 ampere multiplied by the resistance of 50 ohms. So that would be 62.5 volts. And next is the power dissipated in each resistance or resistors. So we get already the power, the voltage drop. So we have the values of different voltage drops. And we also have the value of the current, because we know that power is just equal to the voltage drop multiplied by the current. So we have here at voltage at the resistor 1, the power in resistor 1, so we have 25 volts multiplied by the current 1.25 ampere, so we get 31.25 watts. And in resistor 2, we have the voltage drop of 37.5 volts multiplied by the current 1.25 ampere. So we get the power of 48.875 watts. And in power dissipated in resistor 3 is equal to the voltage drop is 62.5 volts multiplied by the current, which is 1.25 ampere. So we get 78.125 watts. So we have these answers. So the R equivalent is equal to 100 ohms. The total current is equal to 1.25 ampere. And the current passes through each resistors is just equal to the individual current. So we have here I1 just equal to 1.25 ampere, the I2 is equal to 1.25 ampere, and the I3 is also equal to 1.25 ampere. So next is we have the voltage drops of each resistor. So we have V1 is equal to 25 volts, the V2 is equal to 37.5 volts, the V3 is equal to 62.5 volts, and the power dissipated in each resistor, we have power 1 is 31.25 watts. The power dissipated in resistor 2 is equal to 48.875 watts. We also have the power dissipated in resistor 3, the 78.125 watts. Next example we have here, solve the total resistance and the current and the individual resistor voltage drops. So we have here the circuit. We have the V total of 12 volts. we have R1 of 10 ohms, R2 is equal to 20 ohms, and we have R3 is equal to 30 ohms.